Welcome to Lesson 5, using spinners to compare likelihoods. Here we have a spinner, and in real life the way a spinner works is we have a pointer here, and you flick the pointer so it spins around and it stops in a random spot. In this example, it has stopped on the number 3. In this spinner we have 8 equal parts, numbered 1, 2, 3, 4, 5, 6, 7, 8. Because all 8 pieces are the same size, we would say that each number is equally likely to come up, or each number has the same chance of coming up. For example, a 2 has the same chance of being spun as a number 7. So because no number has more likely to come up than any other number, we could just say that a 2 is possible, or a 5 is possible, or a 6 is possible. Think about what is impossible to come up on the spinner. Pause the video and think about it for a second. Is a number 9 possible, or a 10, or a 23? All those numbers are impossible. They cannot come up because they don't exist on the spinner. Let's look at another example. Here we have a spinner with 6 equal parts. But if you study it for a moment carefully, you'll notice that not all colors are equally likely. So pause the video and try to figure out which colors are least likely to come up and which colors are most likely to come up. So yellow and green are least likely to come up. Each has a blank chance of being spun. Let's see if we can use a fraction to determine the probability of a yellow or a green being spun. If we just look at them separately, each has a 1 in 6 chance of coming up. If we put them together, yellow or green, it would be 2 in 6. Now see which colors are most likely to come up. Red and blue are most likely to come up. Each has a 2 in 6 chance of coming up because there are 2 out of 6 reds and 2 out of 6 blues. Alright, let's look at one final spinner and our likelihood scale that we saw in the previous lesson. Here we have a spinner with 4 colors, but each one also has a number. So the red is a 1, the green is a 2, pink is 3, and blue is 4. Pause the video and see if you could figure out where they would fit on this scale. It's clear to see that the number 3 is the smallest piece, so it is the most unlikely number to come up on the spinner, and that's roughly where it would go. The next two numbers, the 1 and 2, appear to be the same size, so they are equally likely to come up. Where would you put each one on the scale? I wrote them in sideways just to show that 1 and 2 have the same likelihood of coming up, but that's roughly where they would go. The 1 and 2 are still unlikely to come up. And finally, our biggest piece is the number 4. Because it is still less than half of the entire spinner, it would be less than the midway mark of our scale. But the number 4 would be closer to the middle line. So the number 4 would go roughly in this spot here. It's the most likely of the 4 numbers to come up. So we can use spinners to learn and to do questions about probability. What is the chance of a 9 coming up on this spinner? Well, it's impossible that a 9 comes up, so we would put it right here on the far left. What is the chance of a 1 to 8 coming up? Well, it's certain that a 1 to 8 would come up on the spinner, so we could say it's 100% for sure. And for any other number, any individual number, 1, 2, 3, 4, 5, 6, 7, or 8, we would probably say that it's possible that any of these numbers come up. And in this example, because all 8 pieces are the same size, they are all equally likely to come up. So have fun using spinners and probability, and please watch the video again if you need help.